Instead, we are taking the area of just a half a circle. So we need to half that sucker up. Thank you, thank you, thank you, Kyle. So it's 170, so it's 88 pi. Oh, my bad. Thank you, thank you, thank you. Cubic units, whatever it is. For us, it's inches because we got inches, but in general, it would be cubic units. Thank you, thank you, thank you. And the second one. We've got our pink paper, right? And on top of that pink paper, we are stacking this time some orange triangles, right? So now we're going orange. Get orange. You can follow the same idea, right? You're going 0 to 11. Now there's something of import that I didn't say, but it's very important. We're going from 0 to 11. We are counting them and stacking them up along the x-axis, and that's why we say their thickness is relative to the x-axis. The thickness for each shape is relative to the x-axis. We could turn and get an entirely different shape if we did it with the y-axis. Are you with me? In which case our thickness would be dy, and we would go from 0 to 8. But right now we're staying with the x-axis. So all of our cross-sections, I will just point out, each cross-section is perpendicular to the x-axis. Hopefully everybody's bored to tears right now because it's going to start getting a little trickier. So I'd rather us be super bored right now for when it gets a little harder, okay? But again, it's the same idea. We're integrating with the thickness along the axis in which the cross sections are perpendicular to, and we're taking the area of this thing. Now, you guys told me the base is 8, right? This is 8 units long. So what is that area? Do you guys have an area formula for me? Where's my, anyways, yeah. What is it? It is 1/2 base times height. Where's my creative problem solving group? Do you guys remember the area of an equilateral triangle by any chance? Alex.
You could literally do half the side length times the height.
You can? What's my height?
Your height is the square root of 48.
Yes, it is. Very good. It is. There's a lot of ways to do this. Let's talk. You can either memorize a formula, which is what I'm going to encourage you to do because instead of doing it each time. But an equilateral triangle has 60 degrees on each of its measures. Okay? So if you like, you could use trigonometry because you know that this is going to be 4 and this is going to be 4, and then you can get your height using trigonometry. You could say that the height divided by 4 is the tangent of 60 degrees. Do you see what I'm saying? So we could take and use our trigonometry. The height divided by 4 is the tangent of 60 degrees. Tangent of 60 degrees is going to be square root 3 over 2. Square root 3 over 2 divided by a half, or square root 3. So the height over 4 is square root of 3. And so the height for that is actually just 4 square root of 3. So the height is 4 square root of 3. Oh, or you could do Pythagorean theorem. You don't even need trig. What am I thinking? Because I like trig. 4, 8, and then use Pythagorean theorem and get 4 times the square root of 3. In any case, I will tell you one thing. Let me see how this goes. So this area would be 1/2 times 8 times 4 square root of 3, which is just going to give us 16 square root of 3. Is that right?
Yes.
Mm-hmm. And so if I did that right. And I'm out of space. Make sure I did that right. Did I do that right? Is that what you guys got?
If you multiply it out, it's the same.
That's what I got.
Mm-hmm. The formula actually, just so you guys have for your notes, you can Google it. Oh, Tina, go back. But if you're looking for an equilateral triangle, which you're going to do a lot on your homework, and also on your review sheet and on your test, if you're looking for an equilateral triangle area, rather than calculate it all out, which you can do, okay, it is square root 3 over 4 times the base squared, whatever the base is. So that formula actually could be used. In place of calculating it all out. I'll give you guys more. All right. Does anybody have any questions? Griffin, what's your last name? P. Happens when we take semicircles and we put them on here perpendicular to the x-axis, and we stack a whole bunch of them. Stacking a whole bunch of them. What kind of shape do you get? What does it look like? Does somebody want to describe it? Reed, what are you getting? What kind of shape is that? Alex, what is it? It's what? What is it? It's like
It's a half a cone.
It's a half a cone. So, yeah, kind of, huh? Something like that. I'm having even a hard time drawing it. Challenge yourself to draw it, right?
All I can think
Challenge
is,
yourself to draw it.
This looks like my worst nightmare in SketchUp. As in, like, well, that's 3D modeling software.
I see. So you got this guy up here, and then it comes down again. And then it comes down again, right? And so you got this shape, right? Oh, it kind of looks like bugles. Half of a bugle. Remember those bugles? Remember, like, or a bird's beak, almost like a bird's beak? Yeah? So we got this shape coming down, right? Do you guys see it? Do you guys see it? So we are integrating perpendicular to the x-axis. So what are we doing? Limits are what? What's our limits? 0 to 11, right? You see, Reed? Right? Because we're going along the x-axis, 0 to 11. Then we got the area of the semicircle, dx, right? It's the same setup as before, right? We're just taking it up one more level. So if I want to get this volume, let's see. The pattern is we're going to integrate a bunch of cross sections. They have a certain thickness because we're integrating perpendicular to the x-axis, so we have a thickness. And we have semicircles going in here. And we already know that the area of a semicircle is pi r squared divided by 2. Because a circle is pi r squared, but we have half a circle, so dividing it by 2. So our job is to figure out what is the radius, right?
Could that radius
Alex.
be its own equation?
It better be its own expression. It better be an expression. It's got to have a variable in it because it's changing. So as x moves, you guys see what I'm saying? It's got to have a variable in it because it's changing. What's my radius? Now, that 2 is going to be inside that parentheses, right? And that 2 is not. Guys, got it? You think you have it? If you think you have it, let me see. Let me see. Now get me a number. Evaluate that out for me, Brandon. Find that out for me. What's that radius? Absolutely. Guys got me a radius? The radius is half the distance, right? So what's the whole distance? Oh yeah, I forgot to label it. Did you guys get me a radius? You got me a radius? So let me give you a hint, right? What's that top equation? What's this top equation here, Patrick? What's that top equation? It's what? Y equals something, right? Y equals 8 over 11x, is that right? And so that means that the distance from here to here, guys, just to give you information here, the distance from there to there is top function minus bottom function. That's how you can think of getting the distance. You can take the top function minus the bottom function, and that tells you, isn't that what we did when we found area between curves? We took the top curve minus the bottom curve. So this distance here is the top function minus the bottom function. So it's 8 over 11x minus 0, because it's y equals 0. And so the distance, the entire distance across that entire distance can be thought of as 8 over 11x minus 0, or just 8 over 11x. That's the entire diameter for that circle, right? Do you guys see that? That's my distance. This to this is this entire distance. Does that make sense? So if I want the radius, it's going to be half of this, right? Do you guys see that? Does that make sense? Half of that. So the radius just is going to be half of that. So you should get 4 over 11 as your radius, or 8 over 22. So the volume would be pi over 2 times r squared, which is 4 over 11 squared with an x in it. Sorry, has the x on it. Dx. And I think everybody can take this and integrate this sucker. I would take my numbers and I would start with them. What is that? 16 pi over 22, x squared, and then you integrate. I did not square the 11. Did not square the 11. Let's try that again. I did not square that 11. Let's try that again. So 16 divided by 2 is going to give me 8 pi over 11 squared, which is 121. And then we're going to integrate that. So it's going to be 8 pi over, what's 121 times 3? What's that, 363? Yeah. Alex?
Oh, wait, no, you did. Never mind, I'm sorry.
Oh, okay. Is that right? X cubed? Did I do that right? Oh, I don't want to do that. Why am I making it so complicated? I'm just going to go slower here. We have 8 pi over 11 squared times x cubed times 3 when I take my integral. And so then I'm going to be smart about this. That's going to give me 8 pi over, and stop me, Brandon, or anybody, if I'm messing up here, Jenna, anybody, 11 cubed, 11 squared. minus 0. 8/3 pi times 11. Lily, did you get 88 pi over 3? Cubic. I want to point something out, though. It's the same process as we've done the entire time. You're integrating an area of a shape, whatever the shape is. And if you're cutting with respect to the x-axis, you're going to have dx. If you're cutting with respect to the y-axis, you're going to have dy. Are you with me? And that's it. That's it. That's how you do volumes by cross-sections. It's actually very simple. The hardest part, I think, is getting that radius, or that area, or that base, or that thing. Who has questions? These are stationary shapes, okay? We're going to talk about rotations coming up soon, and that's when it starts to get a little crazy. That being said, I have 2 practice problems, but I would like any questions that anybody has before the practice question, before the practice. And again, our thickness is running along the x-axis because we're stacking these suckers along the x-axis. So first of all, we're going to integrate from 0 to 11 the thickness of each of the triangles, and then we've got the area of each equilateral triangle. But we know the area is going to have a variable in it because they're getting smaller. They're shrinking. See if we can't draw this sucker again. We've got, base. We got a base. And then we got these equilateral triangles. Equilateral triangles. Equilateral triangles. It's not quite what I want, but it's kind of like a wedge. Yeah, it's coming out like a wedge. Like a wedge. Like a wedge. Horrible picture I just did, but that's okay. And I will tell you that the area for every equilateral triangle is square root 3 over 4 times the base squared. Square root 3 over 4 times the base squared. And your base had better have x in it, right? Your bases need to have x's in it because we're talking distance. Yeah. Square root 3 over 4. What is that base? What is that distance? Again, it's top minus bottom if you look at the picture. It's top minus bottom is the entire base. So it's going to be 8 over 11x minus 0 or just 8 over 11x. 0 to 11. And then you're going to get square root 3 over 4 times 64 over 11 squared x squared. And then you're going to integrate square root 3 over 4 times 64 over 11 squared times 1/3 x cubed. I'm getting square root 3 over 4 times 64 over 11 squared times 1/3 times 11 cubed. And things are canceling on us. It's just 11. 4 goes in here, 16. Let's see. Is that right? Is that what you got? Alex, question?
Yeah, why did you square the 8 over 11x?
Let's see. So the formula for the area of a equilateral triangle, I just cheated and used this form here, which is take square root 3 over 4 and multiply it times your base squared. That is equivalent to taking the base, which would be 8 over 11x.
Okay.
Do you see what I'm saying? Times the height.
Yes.
Does that make sense? So it would all give you the same thing. I think that's right. Can somebody verify? Lilia got that, Anna got that, Chris got that? Questions? I do want to do one more while we're on this track. One more practice, okay? One more practice really fast. But any questions? How are you? Okay? Let's just do the top one. Ignore the bottom one. I'll erase it for now. We'll do that next time. So I'll do the bottom one next time. But I think I want to do the top one. Yeah, we'll get rid of this one. We'll do this one next time. But we're just going to do number 3. A solid has, as its base, the region bounded by the curves y squared equals 4x and x equals 4. Every cross-section perpendicular to the x-axis is a square. Set up an integral that you can use to calculate the volume. We're just going to set it up. We don't want to have to work it out right now, okay, guys? Just set it up. Be our last problem of the day. I'm going to come collect your manipulatives while you guys are setting this up for me, okay? 0 to 4. And we have the area inside is simply a square, right? And what is the base of that square? It's going to be the top function minus the bottom function. What's my top function? My top function is 2 square root of x. What's my bottom function? Negative 2 square root of x. Putting that all together, did you get that your base across the bottom is 4 square roots of x? Is that what you guys got? The distance all the way from here to here is 2 square root of x minus another negative 2 square root of x, right? Top minus bottom. That gives us a total of 4 square roots of x. That's the base of this thing. To get the area, what do we do for the area of a square? We just take the base times itself, right? Base squared. So the area for this shape is base squared. And so if we put this all together, we should be integrating from 0 to 4. 4 square root of x squared dx. I want to point something out. Anytime your shapes that you put on here change, which is going to happen anytime your bases are curves, right? These are getting smaller and bigger. You have a variable in there to account for that getting bigger and smaller. What'd you guys get? 16x? So volume is 16x, 0 to 4, 16x dx, which is what? Integrate that sucker, that's 1/2. So that's 8x squared from 0 to 4. Did you guys get 8 times 16 minus 0 or 128? Cubic units. How yous feeling? Oh, heck, I could make this homework due Friday. Should I make this homework due Friday? No? Okay. We'll just make it due Monday like it is due Monday. But we will, when we come in on Friday, we will review and do one more of these as practice. And then we will talk about shapes created by rotating things in 3 dimensions. I have your tests on your way out. So let me get you your tests. What time is it? Is it time to go? It is. Okay. So I'll hand your tests on the way out. Okay? Everybody, you did great. Check and see if I made any mistakes. Let me I added anything up wrong or anything like that, okay? But overall, the class did wonderfully. Come by if you have any mistakes at all.